This is lesson 13, formulas and functions. You guys should try and do the warm-up. So press pause. A local health club has a large swimming pool. Non-members must pay $6 per day fee to use the pool. Members of the club pay $1, but you must pay a yearly membership fee of $250. How many days must you use the pool to justify joining the club? So we're going to set ourselves up an equation where we've got, so a verbal model would be members, and when are members going to equal non-members, or vice versa. So let's do that the way that they wrote it. So non-members and members. So non-members must pay $6 per day to use the pool. So how would we describe $6 per day? That would be 6D. Members pay $1 per day, but they also need to pay $250. So that's going to be $1 per day, 1D, plus $250. So we're going to figure out when these would be equal. Well, we've got a variable on both sides, so we're going to subtract our variable. 5D equals 250. Divide by 5, divide by 5. And D equals 50. So after the 50th day going to the pool, a member would start getting a break because you'd have non-members and members. The member after on the 50th day, they've paid $250, right? Plus $1 per day, so that's $300. That's on day 50. And the non-member is paying 50 times 6, which would be $300. So then this is on day 50. On day 51, the member is paying $301, and the non-member is paying $306. So on day 51 is when the member starts making it. So if you were thinking, you'd say, well, am I going to use the pool 50 times or less, or am I going to use the pool more than 50 times? Homework questions, we'll go over those in class. Today we're going over, this is lesson 13, formulas and functions. Our goal is to solve a formula for one of its variables and to be able to rewrite the equation in function form. Some vocabulary. A formula is an algebraic equation that relates two or more real-life quantities. A two-variable equation is written in function form if one of its variables is isolated on one side of the equation. That means to solve for the equation. So that would be to say like y equals 5x plus 3. Y is solved for, it's isolated on one of the sides. So our first example, solving and using an area formula. Use the formula for area of a rectangle, area equals length times width, and use the new formula to find the width of a rectangle that has an area of 72 inches and a length of 9 inches. So we want to solve this, use the formula to find the width of a rectangle, so we want to solve this for the width. So we want to solve this equation for W. So we ask ourselves, what is happening to the W? Well, when two letters are right next to each other, that means multiplication. So what would I do to undo multiplying L and W together? I divide by L. And now we've solved for W. W equals A divided by L. So we can rewrite that as W equals A A divided by L. And now what we're given is the area is 72 square inches and the length is 9 inches. So we're given A and we're given L. So we have W equals 72 divided by 9, which equals 8. So our width must be 8. That would make sense, right? Because if we go back to our original problem, 72, our area should equal 9 times 8. That equals 72. So why don't you guys try these? So pause and take a second to try these. The area of a triangle, we want to solve this for h. So we ask ourselves, what's happening? Well, we're being multiplied by 1/2, being multiplied by b. So let's just do these one at a time. What undoes multiplying by 1/2? Multiplying by 2. So I'd get 2a equals b times h. And what undoes multiplying by b? Dividing by b. So h equals 2a divided by b. We solve for h. And we're just asking ourselves, what is happening to the variable? So in this case, what is happening to the r? R is being multiplied by 2 and pi. Well, what undoes multiplication? Division. So we'll divide by 2 pi. Divide by 2 pi. And we get r equals c divided by 2 pi. And it's that easy. Our next problem, solve this for p. Well, what's happening to the p? It's being multiplied by r and by t. So we'll divide by r and by t, and we get p equals I divided by rt. Our last one, solve this for r. Well, what's happening to the r? It's being multiplied by p and by t as well. So what's going to undo multiplying by p and by t? Dividing by p and by t. So r equals I divided by pt. Example 2, rewriting the equation in function form. So rewrite the equation 19 minus 3y equals 8x minus 2x plus 10 so that y is a function of x. Whenever we're saying this, y is a function of x, that simply means solve for y. Okay, so whatever letter or variable they use first, that's what we want to solve for. So if they said write x as a function of y, that means solve for x. Write y as a function of x means solve for y. So whatever comes first is what we're solving for when we're asked that. So we've got our equation, 19 minus 3y equals 8x minus 2x plus 10. And when we're saying solve for y, we want this eventually to say, down at the bottom, we want this to say y equals. We want to solve it for y. We want to get everything except for y on the right side of the equation and just have a 1y equals and everything else over there on the right. So if I'm doing this, I want to get y by itself. So the first thing, we can look at this and we can say, well, I've got 8x and I've got negative 2x. Automatically that turns into 6x. I don't want a constant over there, so if I look directly at my y, I've got negative 3 times y, and this is 19. Don't think this is subtracting 19. That's a positive 19. So if I want y to be by itself, I need to get rid of this 19 and I need to get rid of this negative 3. And like we said before, we need to simplify this right side of our equation. So between addition and multiplication, what are we going to undo first? We're going to undo the addition first. So we're going to subtract 19. Now, while I'm doing that, we're going to also combine these like terms. So 8x and negative 2x is going to combine to make 6x. 10 minus 19 makes negative 9. And now we're going to divide everything. When we divide, and we've got a subtraction symbol or an addition symbol, when we're dividing into a quantity, we need to divide to both quantities. We need to divide into 6x and to negative 9 into both terms here. So 6x divided by negative 3 makes negative 2x, and negative 9 divided by negative 3 makes positive 3. And now we've solved this equation for y. We're writing y as a function of x, meaning that I can substitute any value I want to in for this x and get out a value of y. Right? I could say like x is hours worked and y is your payment. Now that wouldn't work because this is a negative slope, but how about well, maybe hours worked for someone else, and you're going to have to pay them. Here they'd only be getting paid $2 an hour, but so let's try doing this one. You guys do this, and then at the end you're going to substitute in those values for x and solve them. We could make ourselves a little XYT table: negative 2, negative 1, 0, and 1. So you'll substitute those in after we solve for y. So we look at this equation and we say, what's happening to the y? Well, y is being added with a negative 7x, or it's subtracting 7x. This is the exact same equation as y minus 7x equals 8. The order doesn't matter, so here it's a little easier to see what is happening to the y. The y is being subtracted by 7x. So what undoes subtracting 7x? Adding 7x. When I add 7x to both sides of my equation, I get y equals 7x plus 8. I can't combine 7x and 8 because they're not like terms. The 8 doesn't have a variable with it. So there's writing y as a function of x, and now we're just going to substitute in some values. So I'll write y equals 7 parentheses 8, and the first one we'll try will be a negative 2. So what's 7 times negative 2? Negative 14 plus 8 is negative 6. So y equals negative 6. When x is negative 2, y is negative 6. We could try the next one. Y equals 7x plus 8, and we'll use a negative 1. 7 times negative 1 is negative 7 plus 8 is 1. Our next one, we'll substitute in a 0 for x. 7 times 0 is 0 plus 8. So when x is 0, y is 8. And our last one, we'll substitute in a 1 for x. 7 times 1 is 7 plus 8 is 15. So y equals 15 when x is 1. You'll see something that's neat when we solve equations for a variable. My equation here, y equals 7x plus 8. Notice how from each value of y, how we move. From negative 6 on the number line, negative 6, to get to 1, that's 0, and there's 1, we'd go up 6, one more, we'd go up 7. From 1 to get to 8, that's a little easier to do. From 1 to get to 8, we're going up 7. From 8 to get to 15, we're going up 7. It's not a coincidence that we're moving up 7 each time and that there's a 7 right here. There's a special word for that value, and it's called slope, and we'll be going over that in future lessons. Our homework is homework 13, And the question is, how are formulas and equations similar and how are they different?